man. All right, let's start over, guys. Okay, so sorry about that. My microphone was muted. I hope people can hear me now. So telling the story about REST APIs, getting to the point where we're having to maintain, and we've developed multiple REST APIs that are all serving up different kinds of data from different databases, but they're all kind of built on the same technologies. And so now the question I would ask here is, what does the web app framework update look like now when you have a handful of APIs you have to manage those updates for, and a lot of things that could go wrong? You're going to be essentially duplicating a lot of work. So this is the situation that we come into, is that we have a lot of APIs that are serving up a lot of data, but a lot of them look pretty similar. You know, I mean, some have icing, some have fondant, some have toppings, some are vanilla, some chocolate, but at the core, they're all still cakes. And so there's definitely some common things that, you know, we should be able to abstract from this, right? And that's the one thing that we're good at, is abstracting away our concepts. So wouldn't it be great if there was a common language that we could use to access this kind of data? Well, the trick is that we already have that language. There's two of them, actually. We have SQL for talking to the database directly, and we sort of developed a common language around HTTP for talking to this data through a web interface. So and what we find, if we start thinking about the similarities between HTTP methods, like your gets, your posts, your patches, your deletes, and things like that, we get a very close mapping between HTTP methods and SQL commands. So we have a get command, HTTP method, corresponds to, for example, a select command in SQL. Anybody might want to guess what a post command is? Typically with a post, we're talking about making new data and sending it to the server. Close. Insert, yes. With a patch method, we're talking about modifying existing data, and that would be your update. And then, can we guess what delete is? Sure. So this was the trick, the double-sided coin. So we already have this really common, a lot of similarities between these two languages. So wouldn't it be great, you know, if we had the time to sort of make a really high-level abstracted framework for doing this, so we wouldn't have to bake a different cake for every API customer? Well, the good news is that you don't have to make your own. This is what PostgREST is for. So nobody gets my Smash Brothers reference. That's okay. So PostgREST sits. It actually is an application that sits in front of a PostgREST database, and it is the app that you deploy. We'll see where it fits into the whole stack later. So it automatically generates and serves your RESTful API on the fly with hardly any configuration needed. No coding. There's very little configuration. There's actually no config files. It's all done through parameters you pass into the binary. So it actually uses the database for as many things as possible. So the first question, all right, I will do this one first, where it actually fits in the stack. So we had this picture from earlier in the presentation of the typical API stack at a high level. So the question of where Postgres fits here is that it replaces, yes, entirely replaces your application and your web server. So all you need is the database and PostgREST, and you have an API. So the first question you'll probably ask is it fast enough? Is it going to be too slow? Am I going to take a performance hit? And this graph is probably too hard to read from here, but I'll just tell you that it's really fast. This is the Heroku free tier, and it's able to maintain a sub-second response time for up to 2,000 requests per second. So 2,000 requests are hitting it every second, and the responses are coming back in under a second. And that only gets better when you throw more resources at it. So I think that's good enough. We'll actually see some metrics about how fast the responses come back from the server. So it's wicked fast. So now you might be asking me, how does it do this? How is it so fast? Because, you know, the APIs that I write on my own aren't that fast, at least not without a whole lot of tweaking and things. So how can it do this generally? So there's a few secret sauces that PostgREST has. So we're going to play name that programming language from the logo, and I know somebody will get this right off the bat. Anybody? Haskell, yes. Haskell is a compiled functional language. The fact that it's compiled gives it a bit of a speed advantage over your interpreted languages like Ruby and Python. Although, you know, that gap is closing. The more powerful hardware gets too. The next element is an embedded web server written in Haskell called Warp. It has no logo, so we have to deal with the classic red X. And then the last thing that PostgREST leverages to get its performance is the underlying database engine itself. Because when we limit our scope to a single database engine, we can take advantage of all the advanced features that that engine has to offer. And Postgres just happens to be sort of the de facto open source implementation of the SQL standard language. So that was just kind of a natural choice for building this technology up on. And it's super easy to get started with Postgres, if you're not already there. And so the combination of these three factors is what causes, what gives PostgREST such a good performance. So, and of course the good news is that PostgREST, the server, is completely stateless. So you can scale in both directions. You can scale horizontally by adding more instances behind a load balancer, or you can scale vertically by increasing the power of your instances. And of course, because we're talking about databases and we might be dealing with just enormous data sets, this might still not be enough for you. So you always have the option of clustering your database if you want even more performance. So that's kind of advanced. I'm not even going to talk about how you do that because I don't know. So now we've reached the fun part, the first demo, where we're just going to be exploring PostgREST and how it works. So I want to first explain to you the system I'll be using for the basis of my demo. I'm running a VirtualBox VM on my laptop here. It's just running an Ubuntu 14 image. Inside of my Ubuntu image, I'll be running the database itself and PostgREST. Small implementation detail, I'm using Linux containers to serve up and encapsulate my database. So the Linux container is running on this IP address, and the database is being served from inside of that on the standard port 5432. And we'll be connecting to a database called DVD rental. PostgREST, the API engine, is going to be sitting outside and connecting to the database through this IP address. And we'll connect to it from the IP address of the virtual machine. And PostgREST will run on port 3000 by default, and that's about it. And then just a little bit about the database itself that I'm using for the demo. If you've ever used MySQL or gone through any tutorials, you might be familiar with the Sakila sample database. And basically, it just models a DVD store, their inventory, their customer base, payments, and things like that. The object model looks kind of like that, but it's not really relevant because all we really care about is the fact that it has the common SQL things that we expect and what we'll sort of be interacting with. It's got tables, it's got views, it's got functions, and it's got triggers. So that's all that really matters. So with that, we're going to go into the demo portion. So let's see, what do I need to be? All right, the first thing I'm going to do, I have a SSH session here. First thing I'm going to do, I'm going to start completely from scratch. I'm going to download PostgREST, and we're going to set it up right here live on the spot. So the first thing I'll do, I've got postgrest.com loaded up here. I'm going to go to their GitHub page, and we're going to download the latest distribution straight from there. So we're going to find this one. Need the Ubuntu 64-bit distribution. We'll copy that link address. All right, and we're going to download that directly to the VM, hopefully. That didn't take too long. All right, so we have a compressed distributable. We'll extract that with our good friend tar. All right, so what do we get? We get one file. We get one executable, and that's all there is. So what we need to do now is actually start the server, and I'm going to start it as my default Ubuntu non-administrative user. So the command looks like this. I'm just going to execute the server directly, and it'll tell you what you need to configure it. But this is all the configuration right here. There's no conf files or environment variables you need to set up. You just pass everything directly through to the command line. So we'll just do the whole thing right here. The first thing you do when you, the first parameter you pass it is a Postgres URL connection string. And basically this just looks like a standard URL, except it has the little Postgres thing in front of it. Everybody see that okay, by the way? I've got it pretty blown up, so. Okay, so the first thing you'll do is username and password, the user you want to use. There's more to it than that, but we'll get to that when we cover security later on. Rather, that is, password is super secret. So this is a user that I've set up inside the database, and PostgREST is going to use that role inside the database to present me my API. So at the IP address of the database, which is 10.0.3.2 on port 5432. And then we connect. The last thing you have after the slash is the database you want to connect to. Okay, so that's all there is to that. We'll specify a port for the server to run on. The next thing we're going to specify is the schema to expose. Does anybody not know what a PostgREST schema is in sort of the whole hierarchy? Basically a scheme. Right on. Okay, thank you. Specifically, a schema is sort of a container for like your tables, your views, your functions, your triggers. A schema wraps all that up in something that has a name, and you can have multiple schemas in a single database. And the trick is that multiple schemas can talk to each other. Like you can have one schema that talks to another schema, and then there's nothing stopping that from happening naturally. So anyway, we have a schema named public. That's the default Postgres schema that we're going to expose. The next parameter you need is called anonymous. I'm going to gloss over that for now. Use the same user. That comes into play when we're configuring security. And the last thing is pool. And that's just the connection pool that Postgres is going to set up on top of the database and kind of keep it at a limit and not use up so many database connections. Right, so I did it right. Now the server is running on port 3000 on the VM, and we can start talking to it. So we will start doing that. I'm using, we're going to be talking to the API. Sorry. We're going to be talking to the API through two different tools. Mainly, I'm going to be using this one called Advanced REST Client. It just lets you, it's a web-based client for making RESTful requests to a server. The advantage here is that I can zoom in and out as I need to on this one. The disadvantage is that it's a little buggy when we're talking about doing posts and puts. So I have another one that we'll use called Postman, which is my preferred API client. The disadvantage here is that I can't zoom in and out as I want. So the text will be kind of small, but I won't use it for very many things. So now we're going to start actually making requests to the server. So if this is still right, and I make this GET request directly to the server is running on the VM's IP address, and then the port is 3000. If I make this request, I'm going to get back some information. We have an OK response code coming back, and we see that we got this data back in 27 milliseconds. Now I'm cheating because I'm running locally, but if you were to compare this against the response time of a direct database query, they would be almost the same at this level. So when I make a request to the server without specifying anything else, I get back an interesting array of objects, of JSON objects, describing the tables and views that I have access to as this user, as super user. So we have, basically it says what schema that what database schema that I have, what the name of the table or the view is, and whether I can write, whether the data itself is writable. Now, some things that aren't writable are views. Postgres can do views that you can write through. Anybody not know what a database view is? Okay, a database view is like a saved query that you can run over and over again. It lets you encapsulate complex relationships between different tables you have in a way that you can reuse over and over again without having to write out that whole query all the time. And the cool thing about views is also you can treat them as if it were its own table. And that's exactly what PostgREST does, is we can select directly from this view as if it were a table. The only thing we can't do is write new data to it because it's just, there's no way to route that through the view back to the underlying tables. So, small deal. So anyhow, we get this array of objects that tell me what I have access to. So in a way, PostgREST gives you automatic self-documentation of your API. We'll see that a few other places too. So the first thing I want to do is show you what the routes are. So the first thing, the different HTTP methods you have map directly to database operations, like we were talking about. It's exactly the implementation of that "wouldn't it be great if" scenario that I proposed earlier. We have a GET, usually corresponds to select statements from the database. Post will correspond to an insert command. PostgREST doesn't use puts, it uses patches instead, and that's for updating, and then delete is self-explanatory. the only other the only other method you can use in PostgREST is the options request. We'll take a look at that later. So we're going to stick with GET requests for a while and kind of explore the language of PostgREST and how you make requests to it. So we already looked at the root route. So the trick with PostgREST is that it has to be general to cover basically the entire any database you could conceivably create in Postgres. It wants you to be able to expose that. So it takes a hard and fast stance about no deeply nested routes. So we're not going to have routes that look like this. You know, we're not going to have any sort of nested routes like that. We're only going to have routes go one level deep. Yeah, that's it. And then we'll do more filtering on the requests with URL parameters and with headers. So the elements of your route are just your table names or your view names. So we have a table called film in the database. So if I use that as my route and hit send, with no additional headers or anything like that, we're just doing a GET request to that resource. We're going to get a JSON encoded array of every object or every row in that table. This is without any code, any configuration or anything. You just get this. It's automatically generated. Actually, the JSON serialization portion of it is actually done inside the database because Postgres can do that now. So we have an array of 1,000 objects that we got back from the database, and you know, there's some nested arrays. There's text vectors. There's numbers, strings, and all that kind of stuff. And we got that back in less than 100 milliseconds. So I think that's pretty impressive. Maybe it's not, but I like it a lot. So likewise, if we wanted to get data out of a different table, like an actor table, we just say the table name, and we'll get the data back. This time we get 200 objects back. These are objects representing the actor directly out of the database. So these are like your select star without any sort of limits or orders or anything like that. So the thing is that most of the time you're not going to want to get everything back in one request. You're going to want to put some limits and some filtering on what you get back from the API. So what you typically have, the common pattern for RESTful APIs, if you're trying to get like the ID like number 20 out of the API, you'll have a route like that, where the number after the table represents the ID. So the problem is that if Postgres were to do that, it wouldn't cover the case where you have a primary key defined by more than one column. So instead, it says, no, we're not going to do that. We're going to have a different general method of filtering. So what we'll do is we'll start with row filtering. These are your where clauses in SQL. Where row filtering uses query parameters, which are the little guys that come after the question mark, key value pairs in the URL. I'll do a few like this, but I can actually expand this out and add them in a more visually appealing manner, but I'm going to do it this way first. So when you're doing row filtering, the key of your parameter is the table name that you're setting up a filter on. So let's select by primary key. Let's select by the ID. So because that column name is actor ID, my parameter name is going to be actor ID as well. And then my value for that is going to be a what they call a filter expression. And this is specific to PostgREST. You can look this up in the documentation for their API. There's no point for me to show you everything here, but I'm going to show you a few things so you kind of get a feel for how it works. So the filter expressions kind of look like this. This is equal to 1. And then there's multiple different bits you can have there that represent different operations. But this is the equals. And then we're looking for the actor ID that equals 1. So if I send this request along to the server, I'm going to get back a single object that is just that actor. I still have it wrapped inside of an array. There's a way you can have that unwrapped automatically by specifying a header, but that's a little advanced. It's not really worth touching on here. Similarly, if you wanted to get a different ID, 1, 2, 3, do that like this, and you get 1, 2, 3. And this method, the thing about these filter parameters is that you can chain them. you can have multiple parameters for filtering on multiple columns. So if say that I wanted to find, we'll save that one for a future query. Let's try out string equality. Let's do filter on the ratings column. So we're filtering on the string equal to R. We're looking for R-rated movies. And if I send that along, I get a bad request. That shouldn't happen. Actor, because I'm on the wrong table. I need to go back to film. Yep. Live demos, guys. All right. So now I have 196 movies out of the database that are rated R. So the thing you might be asking is, we know that with strings, we typically wrap them in quotation marks to help codify any white space characters or anything like that. Well, you don't want to do that here. Instead, you want to encode the spaces properly, like this. Actually, if I write it there, with this GUI, I can actually hit this button to encode it. And so the space gets encoded as a plus. That's the URL safe encoding for a space. And if I send that query, that's not, I need to change the title. We're going to look for movies with the title equal to this title, Gross Wonderful. Let me get a single response back. Okay. You might be interested to know how you can do negation. You can negate any parameter with an additional filter expression like this. We have the R-rated movies from the previous example. If I append a not to that, that does the inverse of that. It just negates the EQ. So I'm getting some lag here. There we go. So now I'm getting any movie that's not rated R. There's a lot of NC-17 rated movies in this database. I don't know why, but it's crazy. You can also do numeric operations with filter expressions. If we wanted to look for, maybe you guys can guess what this corresponds to. I'll make it a little bit bigger. Let's say GTE.80. Any guesses? Greater than or equal to? Yes. It's pretty self-explanatory, really. So if I filter there, you get back what you expect when the client renders the data. Okay, there we go. So what was that? Length? Yeah, so we're getting movies that are longer than 80 minutes. So we can just kind of do a quick visual check to verify that we're not getting any leaks from other things, but that shouldn't happen. Because it's basically translating these HTTP requests directly to SQL commands under the hood. So I haven't had an instance yet where it's leaked out something where it shouldn't have. Let's see. All right, now we'll do the chaining. We'll add another parameter and filter for something else. We're going to look for movies that are longer than 80 minutes, but cost less than $4 to rent. So we would do it like this. Rental rate is the column. LT is the filter, and 4. So if I collapse this and show it to you inside the URL, we just have these query parameters separated by an ampersand. So that's the standard. Nothing different about that. So if I send this request along, that one took a little bit longer. I think it's kind of hit and miss sometimes, networking. So this time I got 500 objects back that match those two criteria. A smaller subset of the previous query, which is what you expect. One more filter expression before we get on to something more interesting that you're probably wondering about is how do you check for Boolean equality? And you can absolutely do that. We need to switch to a different table though, because film doesn't have any Boolean quantities. We need to go to customer instead. Let's go active bool is the name of that column. And we use the is filter to check for Boolean equality. So, okay. So we're just getting all this active bool is true. See? Yep. No active bool falses in there. So again, this can be false as well. This is also the is filter is how you would check for nulls in the database. There are no in this database there are no customers that are not active, so we get a 0 length response there. But we did get an OK response. It's just empty. There's no content. So let's That's a good thing. That's something that might be hard to account for if you're not being careful when you're custom coding an application to do this stuff. One of the many benefits to adopting a more general framework like this. Okay. That's about it for row filtering. That's the longest part, so thank you for slogging with me on that. Let's look at something a little bit more interesting, column filters. So all of the requests we've been making so far are akin to your select star, where you're getting all the columns back. But there might be situations where you don't want to get all those columns back. If you're just looking for the IDs, or if you're just looking for the links, it's all the other stuff is just noise. So luckily, PostgREST gives you a way to do that. Again, we're using query parameters. We'll go a little bit bigger here. So we're going to use a keyword. This one is always the same, select. That also means you can't have a column named select, but the database engine should keep you from doing that anyway. So the value for a column filter is just a comma-separated list of the columns that you want to get. So I'm going to switch back to film database table. We're going to go title, release year, rental rate, and rating. Okay, and send. So I'm going to get back the same number, 1,003 films in the database, but instead of getting the whole thing back, I'm just getting the columns that I asked for. So I think that's pretty handy. Column filters, that's really about all there is to it. There is a few more things I'll show you can do with them. One thing that you might be interested in is doing type coercion. If so, we're getting, for example, rental rate back as an integer. We're getting it back as well, no, that's not an integer, is it? That's a decimal. That's a number. We're getting it back as a number, and it might be the case we want to have that back as text, as a string instead, for some reason. So we can actually use PostgREST, the database engine's syntax for type coercion with a double colon and then the type you want to force it to, and it will do it for you. And that's just right inside of the query parameter. And so now we're getting rental rate back as text instead of a number. Obviously, if I were to try to cast this guy to a number, I would get an error back from the engine. We can try that. I haven't tried that yet. This is how I crashed the demo. What would be the type there? Is number generically a number a type? We'll find out. We should get an error one way or the other. Okay, we got a bad request. Type number does not exist. All right, so that's sufficient. But the point is that it didn't crash the server. we got a bad response like you would expect, but the server is still running. It's still doing fine, and we got that bad response in pretty good time. So the last thing, of course, you can do is, well, I guess let's see. How did I do this? Okay, there we go. Sorry, I had to rewire my brain here. So column filters and row filters can be mixed, just like multiple row filters. So if you wanted to also filter the columns back on this, it's pretty easy. Rating equal to NC-17, and you'll see how many NC-17 movies are in here. 210. I don't even think that many exist in the real world. Anyhow, this is all sample data anyway, so Markov chains and stuff probably. All right, that's all on column filters. Let's think about when we might want to order the results that we get back. So typically when you make a select against the database, the order that the rows come back is not defined. Actually, PostgREST does caching for you. So if I were to make the same GET request multiple times in a short period of time, they would come back in the same order because the API engine's actually caching the response. But you can't really count on that. So PostgREST gives you a built-in mechanism for ordering your results. And again, we have a reserved keyword for a query parameter for that. You can probably guess that it's order. And your value is the column name you want to order by, and optionally a direction, ascending or ascending. And you can comma separate these, so you can have multiple orders. So we'll just do one. Actually, that's fine. Rate the column ASC for ascending, and we're going to filter beyond that by release year, descending, and finally by title default behavior. Default behavior, I believe, is descending. All right, if I send that request along, I get an OK, and I get, if I can scroll down, there we go. We are now ordering by rental rate, release year, and title. So the trick is that all the release years in the sample set are the same. But the rental rate, we're ordering by rental rate, and then we are ordering by alphabetically. So we have all the $1 rentals before we have the $2 rentals and so on and so forth. Let's see. Let's do, what do we got? All right, I got one more. I got one more type of shaping the response you can do, and that's limiting the response. So this is your limit statement in SQL. It uses HTTP range headers, which are typically used for implementing resumable downloads. PostgREST uses those to limit the number of rows that are coming back. So this is done by headers, actually, not query parameters this time. So we get to see something different. Headers, of course, are key value pairs. So you need two headers for doing this. You need one that's always the same, range unit. Your range unit is always items. And then you have the actual range, which is in this format. Waiting, there we go. X and Y. So all the rows between X, 0-based, and Y. So if I do like this, I'm going to get one response back. Let's see, that's what I want to do? Yep, okay. So that's no additional filters. That's just the film table. But I'm saying that I only want one response back. So we should see something interesting here. The response code has changed. Instead of getting a 200 back, we're getting a 206 back. And that means partial content. So again, that's another thing that would be very tricky or you might miss when you go to implement this kind of stuff on your own. And of course, we have the one row back in the response. So of course, if you want to get your rows back in batches of 10 for like pagination, you do this way. Content, we're getting the range from 0 to 9. So we should have 10 rows back. In the response, we get partial content again. That's a good sign. And we get 10 objects in our array. So that's good. We like that. And of course, the next 10, you could just add these up in your code. Have some variables that would do this for you. 10 to 19 would be the next batch of 10. Of course, I'm not doing any ordering or anything like that here. You'd probably want to do to specify the order that the rows are coming back, so they're not just being randomly sorted. You probably want to do something like specifying an order on alphabetically, like title, ascending. So that would say we're getting orders back sorted alphabetically, the second batch of 10, basically. So the last thing you can do with range headers that I'm going to show you anyway is doing an open-ended range, starting at a certain number and just getting all the rest. Let me do that. Got a bad request. What did I do wrong? Column film.10 does not exist. Oh, yeah, that's not right. We'll just retype that. And we got, sorry, this client's a little slow. Those are the results we get back. Basically all the rows, but the first 20 rows, yeah. So that's what we get back. So that's pretty much everything that has to do with filtering the response. So now we can do some more interesting things that involve writing to the database. So everything that we've done so far has been using the get method. And the reason that is because we had to learn what the filters and stuff are before we started doing writing to the database. Because has anybody ever done delete from database without specifying the where clause? Yeah, so you can do that. PostgREST won't stop you from doing that. Yeah, there's some requests to try to bake in some dummy proofing there, but right now it's exactly what you say that it is. So so we had to learn how to operate the filters and shape the response before we could start doing writing new data. So we'll do a few examples of that, and then we'll get to the security bit, which I find very interesting, and maybe some of you guys do too, because you're probably just itching to put this into production. Okay, so writing. All right, guys, I'm going to switch to my other REST client because this one here is kind of buggy when it comes to sending data to the server. It like tries to cache things, and you'll just get duplicates, and it'll be kind of a mess. So sorry, this is as big as I can make the text. If you can't read it now, maybe you can go back and watch the recorded video. Oh, or there's plenty of space in the front couple rows. Don't move if you don't want to, though. Okay, so the UI is a little bit different here, but the things come back the same. So we're gonna be writing data to the server. So the first thing we're gonna do is an insert, which corresponds to the post HTTP method. Now when we do an insert, we have to send a body to the server as well. We have to send the JSON object that we want to write to the server. So I just got one I'm going to copy and paste in here somewhere. There we go. We're going to make a new actor. We're going to post this JSON object to the actor table. The first, I'll just do a select just to make sure that I'm getting fresh data, that my connection is good. Okay. Now here's where I want to show you the options method you can do. Actually, I'll do it over here because I can make it a little bit bigger. We'll go with options on actor. Apologies if I'm moving kind of fast. I know this might not track very well on the big screen, but it's just the way that I work, I guess. All right, we're going to delete these range headers because they won't apply to this request. Okay, doing an options request on a route gets you metadata about how the data is actually structured in the database. So I did, request options on the actor route. So instead of getting actual actors back from the database, we're getting an object back that describes the database table. We're getting an array of columns that describe what the default value is. That's kind of important for what I'm going to talk about. What the name of the schema that it's in, the name of the column, what data type it accepts. So again, this is self-documentation that you didn't have to write or you didn't have to implement. It's just there. I love it. Okay, let's go back and actually write a new actor to the table now. Armed with that knowledge, we can read that response back from the options and see that the only required columns for new data are the first name and the last name. And I should have that still on my clipboard. Great. So if you don't, whatever values you don't specify, the database will try to write the default value that's defined for that table. If there's no default value and it can't be null, then you get an error back. Just the way that works. So I'm going to write a new actor to the table, Leonardo DiCaprio. I know you can't see it. It's kind of hard to see anyway. I got a 201 response back from the database, and that means I created a new resource. No response actually in the body because there's no data to come back. There is actually a way you can get back the object you just created, but that's a different deal. Now, what I did get back, and I know this is really hard to read, guys. I'm sorry. Is the new ID of that actor in a header. So I can check to make sure that it exists by doing a select. We'll do a select. We'll do our row filters. Actor ID equal to that number that I got, 203. And if this worked right, I should have a new object in there that represents that new actor that I created. So the eagle-eyed viewers might notice that I spelled Leonardo DiCaprio's name wrong. I spelled his name DiCaprio, and I apologize. But I can fix it. I can do a patch command to fix that, to update a resource. So patches work just a lot like posts do, except you only have to change, or you only have to provide in the body the data that you're going to change. So I don't need to specify the first name because it's already there. I'm just going to specify the last name. And I'm going to fix it to say DiCaprio. Now, if I go ahead and hit OK now, I'm going to be all right. If I deleted this, what do you think would happen? Bad things. You're going to change the last name of everybody in the database to DiCaprio. And somebody might like that, but a lot of people might not like that. So let's make sure that we have that filter on there, guys. Right. And if I hit send, I get back 204. It was a successful request. The server successfully processed the request, but is not returning any content. So that's what we get back. Some headers back that are some maybe relevant data. Anyhow, so that's how you would update existing data in the database using the patch verb. And then the last one we'll do as part of this demo. I think that's the last one. Yeah, that's it. Okay, cool. And we'll move on to security. And already approaching an hour very quickly, guys. Bear with me. The next demo is much shorter, I hope. Okay, so you know, I just added this actor to the database as an example, but now I want to get rid of them. So I can do that just by changing my method to delete with the URL that I already have here. It's going to delete that actor. Again, if this is not present and I hit send, it's very bad. It will delete everything, all the actors in the database. So again, just like doing SQL, you have to make sure that your filters are appropriate when you're doing massive updates or deletes or hopefully not massive anyway. Okay, so I got a successful request. I can try to get that actor and see if he's still in the database, and I get an empty body, which means he's gone now. So no more Leo DiCaprio. Sorry. Okay. So that is pretty much the nuts and bolts of how you work with PostgREST. It's a pretty simple language once you understand it. And the great thing is that it's general. You know, it will work for any database that you expose it to. Just a few, to answer a few questions about some other, I guess first let me ask if the audience has any questions about anything that I've shown you so far. Huh?
Well,
Yes, sir.
I think one point that people might wonder about is that on your PostgREST command, when you started the server,
yeah,
you gave the username and password on the command line, but there are ways to avoid doing that.
Yes, yes. That'll become more important when we do the security stuff. And that is actually one thing that is an open issue on, is that, you know, if somebody gets in here on the server and does a PS or a top command, and they know what they're looking for, they're going to have exposed username and password or they're going to have the credentials of the user you started the server with. So typically, if somebody has access to that on your server, it's kind of game over anyway. But that's definitely one thing that some people are trying to get changed, and unfortunately, we might see future versions of PostgREST to require this stuff defined in environment variables or a configuration file to keep it from being so easily exposed. So that is a valid concern, though. Thank you for bringing that up. Anybody else have anything they're wondering about that I haven't touched on yet? Okay. So a few things that you might ask yourself is, everything that we got back and everything we put into the database was all in JSON. And JSON is great for you know, being a lightweight data exchange format, but it may be preferable to talk to or have the data come back in a different way. Can maybe anybody think of what some other formats would be that you would want to have the data come back instead of JSON? XML, yeah, you're on your own. No XML, sorry. How about CSV, column separated values? That's a really handy thing if you're like dynamically generating HTML tables. You can pull that directly from the API as CSV. I'll demonstrate that real quick because it's easy. I do a film, and then I need to specify a new header and say accept text/CSV. If I do that, instead of getting my data back in an array of JSON objects, I'm going to get it back as terribly formatted CSV. But the great thing is that you can import this directly into Excel. You can automatically generate tables off of it. You can also do bulk inserts with CSV. I'll leave that as homework to you guys, though. It's pretty straightforward. But that way, you're not having to write a whole bunch of JSON by hand or in your code. If you have it in CSV already, you don't need to convert it. Versioning. We tend to run and develop APIs in different versions. And what you'll see is a lot of APIs encode the version in the URL like this. Like v1/ and then you'd have film or something like that. PostgREST doesn't do any of that. Instead, they recommend that you run different instances of your server on different ports, exposing different schema. So like the ideal method is that you would have a schema called like API version 1 that has all of your data inside of it, or your views to your data. And then if you need to make a new version, you'd make a new schema with new views and then run them side by side. Probably doing some fancy stuff in the background to make it look like they're running from the same server, doing reverse proxies and stuff. So there's that. One more thing I ought to touch on, because it's kind of important to security, is PostgREST actually allows you to call stored functions in the database. And you do this with a post command. I'm going to switch back to postman for this. If I post, and there's a special route you use for calling functions. If you go back to the root route and try to find the names of the functions we'll be calling, you won't find them because it doesn't expose that kind of stuff. But if you know what function you want to call, it's pretty easy. You have a special route called RPC, remote procedure call. Thank you. Brain fart there. And then the name of your procedure. So in this case, I'm just going to example film in stock. And then if I post an object that represents the keys, the parameters, the input parameters of that function, I can actually call the function directly from PostgREST. And I'm pulling this off of my notes because I know the database, unfortunately. P store ID 1. And I have this object, it's the parameters that's going to go into that function. And if I send it, I'll get back an object that represents the return values. I can't really tell you what that is. It's just a function that I found that works. But I got data out of it. I got an OK request. So that will actually be important when we talk about security, because you can actually implement security and identity management directly into your database with stored functions and procedures, which is rad. So, OK, let's go back to the slides. Appreciate your patience with me. So let's talk about security with PostgREST. We know that security, when we're doing exposing data out to the web, is a very important thing to keep in mind. So the first question you might ask, does it talk SSL? That is to say, is there any way to encrypt the traffic coming in and out of the database or out of PostgREST, the API server? And unfortunately, PostgREST does not give you any way to do that directly. The good news is, come on, where is it? There it is, okay. The good news is that it doesn't need to. We already have tools that'll do this for us. And that tool is, we have a request coming in, and if we put Nginx, which is a web server like Apache, one of the things that Nginx does very well is doing reverse proxies. Basically, we can have Nginx accept SSL. That's embarrassing, isn't it? My pin it button? Anyway. Sorry. You have Nginx accepting the SSL connection and then talking to the backend servers over an unsecured connection. Now, so there are risks with doing this as well, but if your Nginx and PostgREST instances are very closely located on the same server or in the same data center, the security concerns are not so bad. But basically, there's no way to do end-to-end encryption with PostgREST. PostgREST doesn't do any SSL or anything like that, so that's just something to keep in mind. You can still encrypt the traffic coming in and going out through a reverse proxy like Nginx or a load balancer, but that's just one thing to be aware of. And also, if you don't know, you could use Nginx to reverse proxy and load balance multiple PostgREST instances. So that's how you would accomplish something like that. Right. Next question is, how do we do user management? I was making requests as the root user through the API, and it's probably something we don't want. So how do we authenticate requests coming in, and how do we authorize them and make sure that they're accessing something they have access to? And that's a really valid question, something they thought about for a long time. Anybody know what this logo means? Anybody seen that? JSON Web Tokens, yes. So JSON Web Tokens are one of several competing standards for doing authentication by encoding JSON objects and putting them into a header. So again, yes, JSON Web Tokens. Right, so the idea is that you have a JSON object. In this case, the only thing that PostgREST cares about that's in this object is a key called role. You can probably guess that the role you have in your web token is going to correspond to the database role that you get when you are talking to the API. So you add the JSON object itself to a secret encryption key or whatever, a secret, and you get back this ball of text that you can actually decode to represent this, if you have this. And that's what PostgREST does. So there's a few things we need to set up for this to work. Remember when we started the server the first time, we had that anonymous user? Well, the anonymous user is the user that an unauthenticated or an unauthorized user gets when they try to access the API. If they don't provide any authentication parameters, then they'll be accessing the API as anonymous. And then if you have whatever your anonymous role is in the database, it'll have whatever permissions are through the API that user has in the database. So you can make your API secure from public by not giving this user any permissions. The authenticator user is special. The authenticator user is what goes in your PostgREST connection string. We'll see this when I do the second demo. The authenticator user has just enough permissions to assume the role of a different user. And so what this means is I'll show you what that means. So an unauthenticated user gets the anonymous role. An authenticated user, they provide their JSON Web Token in as a header. PostgREST will decode it if it can to a JSON object itself. And then if everything goes well there, it's going to check to see if this role is valid. And then you will log in as the authenticator user, but then immediately the authenticator user will assume the role of, in this case, administrator. So you can have multiple users, and then of course the request goes on as normal as the new user that you've assumed the role of. So a few things to note is that you can actually, because if you implement this, you'll have access to the JSON Web Token secret. And so you can actually generate the token externally if it uses the same secret and it has the same object. PostgREST will decode it correctly. But using some advanced things, you can actually implement this whole implementation of security with users and things like that directly in the database. Now, that's detailed in the documentation. I'm not going to show you how you set that up, but the only thing you need to know is that I have that set up for the next demo that I'm going to do, where we're going to have a couple different users coming into the API that have different roles, that have different permissions, and we'll see how those users have some users have access to some things and some users don't have access to other things. Okay, so that being said, we're on to demo 2, hospitable takeover, and we will definitely finish here within the next 20 minutes. Okay, so remember the DVD store that we had from the first example? Well, it's been assimilated. They went belly up, and somebody has now bought them. A company that we all know very well for being really up with the times and being very modern. The Bluth Company from Arrested Development, if you don't know. So what we have is we have an API for the store where the API is powering two things. It's powering their internal administration panel that the workers use to update all the information in the database. But there's also one small publicly accessible thing that's hooked into the public website to let users search for movies that they carry. So what we'll see, we have a president. This is Michael, of course, because Michael gets saddled with all the hard work. Michael has all access. So because the previous demo did requests with an unrestricted user, we won't be doing any demos with Michael because we've already seen how that works. You just have access to everything. You can delete stuff, you can update stuff, insert stuff. Very dangerous to be that person if you're not careful. So the next thing the store needs is an accountant, and Lucille, Michael's mother, is very adamant about putting a certain somebody in that position, and Michael puts up a very strong fight, but in the end loses out. And in that position, we put Job, unfortunately. So Job, the accountant, has the permissions to list and modify payments in the database. He also has permission of the next user we'll see, because permissions kind of build incrementally. We're working from the top down. The last user, second to last user we have is the worker. The worker is, of course, Michael's ever faithful son, George Michael. Not that George Michael, this George Michael, sorry. George Michael Bluth, he's the worker. So the worker, he is operating on the inventory. He has the ability to list films, categories, actors, languages, customers, but the only thing that he can do, he can't delete any of that stuff, he can't update any of it. The only thing that he can really do as far as the data creation aspect goes is creating a new rental. That's like bringing somebody up, at the register. The last user we have is John Q. Public, who's this guy, old movie reference. The only thing that John Q. Public can do from the public website is list films. Right? That being said, we're going to move on to the next demo, and this should hopefully go pretty quick because I think it'll be pretty obvious. The first thing we need to go back to the server and start the server with different parameters. So that's the first thing we'll do. So it's going to be pretty similar to the last one. I'm going to change a few things though. Our user, instead of being super user, this is where your authenticator user goes. So you'd use the authenticator user, which I just have named authenticator for the purposes of my sanity. he has the same password because we do password sharing here. That's what we do. We're connecting to the same server, connecting to the same database. We'll be using the same port. We'll be using the same schema. The anonymous is going to change though, because we don't want anybody logging in to have super user permissions. So we're going to change that to a different user named Anon, which is my anonymous user, who only has access in the database to list films. So, and then the last thing I need to define is the JSON Web Token secret. And this is another one of those parameters that could be exposed in the case of somebody getting access. Again, this is one of those things that might be moved to a configuration file in later versions. So that is JSON or JWT secret, if I can spell secret right. There it is. We're going to call it super duper secret. We'd probably not want to use some regular string here. You'd want to use some sort of randomly generated thing. But if I use this secret here to start the server, and then use that secret in somewhere else to generate tokens for users, you can have external authentication. But I'm generating my tokens actually through a login procedure that I have in the database. So I'll show you that as part of that implementation. Okay, I've got PostgREST running in the background. Let's see. That'll work. Yep, okay. There we go. You can actually run different instances side by side, but they can't bind to the same port. We know how that goes. Okay, we're going to go to the client we can actually read. All right, the first thing we're going to do is log in as John Q public, which actually doesn't require any logging in because we don't need to pass in any authentication parameters to do that because that's the anonymous user. So if I go back and just do the root request with no additional routes and hit send, what am I going to get? I'm going to get, actually this is something that I think I needed to change. He shouldn't have access to customer, so he should only have access to film. But you can actually see though, right, that that this user has a much smaller subset of things available. Even if this user knew that there was an actors table under the hood, like this, and he tried to make that request somehow, by hacking in with his credentials, he would get a 404. So he doesn't even know that that resource exists. There's no way for him to find it out. Even if he knows that it exists, he can't get to it. He can't get to that data. So, and this stuff, so I haven't read the source code because it's in Haskell. Maybe Tanner can help us out. But the author claims these functions to be leak-proof. I personally trust that. I think at some point you have to kind of defer to authorities when you can. But anyhow, so let's look at something he does actually have access to. Get film. And we're actually going to do a filter on this. Oops, let's do this right. Not like that. Right, apologies. I have some custom CSS I have on this page to make it a little bit more visually appealing. Let me find that and put that back in. I refreshed the page accidentally, so I need to redo that. I tried using something like Grease Monkey, but it didn't work. Let's see. All right, cool. So let's do this, right? We're gonna go to the films table as John Q public, anonymous. Send. And we get, for some reason, a bad request. Unexpected input of field name. Let's see, what did I do wrong? I bet there's something being cached here. Okay. Slash, okay. Yeah, this client's really buggy, guys. Sorry about that. Let me try it here. Okay. Phil, please give me something. There we go. All right. So this is the unauthenticated user. He's got a list of all the films. He can do filters on this. You can type in a search box and do some filters. So he wants to look for a movie named like this, EQ adaptation holes. And if I do that, I get nothing back. Maybe I need to encode this. Sorry?
Yeah.
Okay, maybe like that. It's not there. We did this one earlier, right? Maybe I spelled it wrong. There we go. All right. So it's probably just something that I typed up wrong here. All right, so he can filter and find. He has full permission to read from the database. But now, if something were to happen, if there was a bug in the UI that gave him access to delete movies from the database, he has access to this table. It shows up in his thing. But if he tries to go in and delete this movie, he's actually going to get denied because the anonymous user doesn't have write privileges to that table. So this lets you really centralize all of your access control to your database through the use of database rules. So now let's log in as George Michael. So the way we do that, I'm typing RPC login. I'm calling a function called login. I'm going to post to it because we're calling a procedure. I'm going to post a body, a JSON body, with my username and password. My username is George Michael. My password is, unfortunately, password. If I send that, I'm going to get, in response from the server, a web token. And this web token I can use to authenticate my further requests. So I will copy that token, the whole thing, and I'm going to put it in a header. I'm going to put it in a header called authorization. I'm going to delete that header. No, I'm going to delete that header. There we go. I'm going to use some autocomplete to help me out here. So the way this works is you say bearer, or is it, how does it go? Is it lowercase bearer? Maybe uppercase bearer. We'll try it. Bearer, and then the whole web token in the header. So if I go back to the root route and look, you'll see I should have access. I should have more things in here. I don't have everything because I'm only a worker, but I have access to more data here. So what George Michael finds is that he finds a movie in the database that he really likes. He finds a copy of The Dangerous Cousins, and like this, we're using a like filter. We didn't go over this in the presentation, but you can probably guess that it's like doing a fuzzy search on in the database. So there's the movie. So he decides that he wants to remove this movie from the database, and he wants to keep it for himself. He lost his old copy. So so he figures, well, I'll just delete this guy, like, because I have access. I'm a worker. I can delete this. Well, no, he can't. Unfortunately, he has no permission. He gets permission denied on that. So, but what he can do is he can make a new rental, and so he's going to find a random customer to rent that to, and he just kind of types in a random customer ID, like so, 600, and he's going to rent the movie. We're not going to delete that guy. We're going to get that guy. We're still, we have to keep this authorization header in because that is identifying us as George Michael. All right, we got Barry Zuckerkorn. We're going to rent this movie too. So we will. Sorry, I'm a big fan, so I have to pay homage. All right, so we're gonna make a new rental. So like the way you would do this is you would call options on the rental table and figure out what parameters you actually need to pass in to make a new rental. I just have it already written down, so I'm gonna copy and paste it. What is that? I have no idea. Okay. All right, this is going to be our JSON object that makes a new rental for that movie. And when we do this, it will not show up in the database anymore. Well, it won't show up in inventory. It'll still be in the database, but it'll look like it's out of stock. That's what George Michael wants. So we do this. We make sure we're posting a good object. Hit send. Permission denied. Okay, I have some permission sequence stuff. He should be able to write to that table. Let's pretend that he did, okay? So that's all we do for George Michael. So the next thing we're gonna do, we're gonna operate as Job. Job's gonna log in. He gets a directive from Michael, the president, and says, hey, you know, we had this customer, we have Lucille Ostero, has rented a lot of movies from us, but she's majority shareholder of the Bluth Company, so we need to go back and give her all those, retroactively give her all those movies for free. So hey, I need you to go into the database and change the amounts that she paid for all those movies to nothing, to 0. So Job says, okay, I'll do that. So the first thing we'll do is we'll log in as Job. I'm going to pull up my history here to save myself a little bit of time here. Okay. So I pulled up my my last request to log in, and I'm going to change the username to Job. His password is also password. They don't really do security at the Booth Company. So I get a token back. I get a different token back. This one identifies me as Job. And I want to stress again that all this implementation, the login and things like that, is directly implemented in the database with, I mean, there's no additional code running to prop this up. That's just all there is. So now I can make this my authorization header. Here, instead of George Michael's token, I'll paste in Job's token. And if I do a get on the root route, I have even more things I have access to in the database. Okay, so, and now Job does a good job here, for the most part. He's going to go into the customers table and find Lucille Austero, the customer, equal Austero. Okay. Okay, there we go. So we have Lucille Austero's ID is 601. So we'll use that to inform our future requests. All right, we're going to go to the payments table now. Payments, and we're going to find all the payments with the customer ID equal to 601, EQ 601. Now we're going to get all the payments that Lucille Austero has done. Well, that's great. So now all I have to do is update these guys, right? Let's see, payments, patch, body. Okay, we just need to change the amount. That's all we need to do. Not a big deal. Amount 0. Great. There we go. That feels good. Oh wait. Did I do something wrong? Did Job just make a huge mistake? He did. What did he do? He changed all the amounts to 0. But he doesn't think anything of it. But Michael finds out. He gets really mad. And Job comes in the next day. And so Michael immediately calls the IT guy and tells him to demote Job to a worker. Like, I'm not going to have this anymore. So the IT guy goes in. All right, I need to reconnect. This is pgadmin. It's a terrible UI for dealing with Postgres databases, but it's functional, so we use it. Come on. We have a, where is it? Yeah, there should be tables in the basic auth. There they are. They were just not updating the UI. Remember how good I said the pgadmin UI was? Yeah, that's what I meant. We're going to go into the users table. This is part of the implementation. I copied this directly off of their documentation. So it's they build it up as like a blog thing, but all we need to do is go in here and change Job's role to worker to be like George Michael, and then that's it. His database permissions have now changed, but he doesn't know. Michael forgets to call in. So Job comes in the next day. He's going to log in again like normal. What he doesn't know, why? Okay. What he doesn't know is that he's actually going to get a different token because his role has changed. But he logs in like normal and doesn't see anything. Job password. So, all right, we got a different token now. He doesn't know. He's gonna after he logs in and before he gets any work done, Michael calls him up, tells him the huge mistake that he made, and says that he got demoted. Well, Job doesn't like this. He knows that in the past he's been able to delete customers, so he decides he's going to take his revenge out on Michael and delete all the customers too, because he's got better things to do, like raising bees. So we will make a delete on, we need to paste in his authorization, bearer, his new token, okay, customer. He's going to delete all the customers, because Michael doesn't know what he's talking about. Well, okay, I have some constraint issues, but suffice it to say that he doesn't even have access to that anyway, because his role has changed. So these are just some examples of the controls you can put in when doing security with PostgREST. So any questions about security? Yes, sir.
In the table of user data, I saw a big long string of characters with each user. Is that their token?
That is actually their password encoded.
Okay.
There's an extension That was a good thing you brought up. This is kind of an implementation detail of how this gets done. But this is the pass. It's a password column. It's called pass. But there are triggers in place that whenever we make new users, it will encrypt the plain text password that we send to them. And the login function actually encrypts the password you send and checks to see if they match. And if they match, it'll give you a token. So these passwords, these are their passwords. They're actually all the passwords are the same. They're all password, but they're encoded differently because they're using different parameters, different salts, whatever. But this is a PG crypto, an extension they had you install. So you don't have to implement any of this as well. Any other questions about kind of how some of this stuff works? No? Okay. We are almost done. We are crossing the finish line. We have a few more slides. Okay. So here are some final thoughts. We're going to pin this image? No. All right. Here's some final thoughts about where I think PostgREST fits in very well. So we have to ask ourselves, what is this really good for? You know, is this a curiosity? Is this something we can actually put into production? Is this something we need to test really rigorously? Well, or, you know, is this going to replace REST APIs entirely? You know, like these are valid questions we should ask ourselves. So I would argue that that's not the case. I would argue that it shines really well in a couple different cases. Of course, you could implement it in other cases if you wanted to, but these are kind of my personal opinions. So if you have a relatively new project and your domain model, which basically says how you model your application objects in your code, if they map pretty closely to your database tables, like if you have your objects are connections, and in your database you have a table called connections, everything's kind of one-to-one, that's a really good application of PostgREST, especially if it's a new project because you don't really have any cruft. You can just kind of go directly from the database tables, sort it directly with PostgREST, and you'll have a really great, robust API automatically for you. The case for appliance was we had a relatively old database. There's a lot of data in there, and you know, we just weren't really sure if we wanted to expose all that directly through an API. So you have another option. So all of our data, all of our views, functions, we have some triggers, and the public schema. Well, this is not what we wanted to expose as our API. What we wanted to do instead, or what you can do, because you can talk across schema, you can make a new schema that will end up being your PostgREST API schema that you can kind of grow as you want to add new things to your API. We're adding new views that deal with this data under here. And that gives you a way to slowly grow an API and figure out what you really want to do with it from an old database, from kind of legacy data. And in this case, actually, is really cool. You know, one of the things I haven't even touched on is that when you do this, when you adopt PostgREST, your DBA can become your API guy because there's no code to maintain for your API, which is, I would argue, is a good thing because it frees your developers up to solve some of your more complicated problems. Maybe some developers who like writing APIs would fight against this, but I guarantee that we can find better things to do with our time than re-implementing the same thing over and over again. So by adding new views in the database and assigning the permissions correctly, you automatically have new endpoints to your API. You don't need to write any new code in your application to expose those things. They're already there. So then the question is, would we expose a PostgREST API publicly? Which basically means, are we going to make it available directly for other developers to consume? You could do that. I don't think there's anything technical preventing you from doing that. I would argue maybe that you wouldn't necessarily want to do that because PostgREST, you know, takes some opinionated viewpoints about how it handles the routing. You know, a lot of APIs like to do the nested routes thing, you know, film/1 or film with the ID of 1. So you might not want to do a PostgREST API directly to the public, but I think making a wrapper API that talks to PostgREST on the back end is something you could do pretty easily and still have a really robust API. How about private APIs, like back-end or internal APIs to power intranets? I don't see any reason why you couldn't just do that directly. You know, if other developers aren't going to be consuming those things directly, then, you know, I think it's great. You don't have to spend a whole lot of time implementing this thing. You don't have to write web services. You just put it on there and go. and then you can start writing new clients and all this stuff without having to worry so much about the back end. It's all just kind of taken care of for you. So what about competition? Is there any technology that's other technology or applications that are doing the same kind of thing? There's a few. We have a couple different projects, but most of them aren't very good for one reason or the other. We have a MongoDB REST. It only works with MongoDB, implemented in Node, has no concept of security, so probably don't want to do that. We have one called Automatic REST API, PHP MySQL. Again, no security, so not really good for production use. There's a project called PHP REST SQL. Again, works on implemented in PHP, works for MySQL. This project is dead by like 3 years, so I would not recommend putting that in production. They might have security, but again, if an open source project is not maintained, it's not a good sign. A project called RESTDB. This was a little interesting. It's implemented in PHP, but it works for any of the 3 major databases, PostgREST, MySQL, or SQLite. A couple problems though. No security, of course. Security is hard, guys. And it's also dead. Dead for 1.5 years. So rip in peace. The one more that I found, I was just kind of off the wall. REST SQL is a database. It replaces your database. It aims to replace your database that has a REST API built in. It's written in Java. You run it and deploy it on a Tomcat server, and the data under the hood is persisted as XML, even though it's being served as JSON. It's just one of those things that, like, I mean, maybe somebody has good use for this, but I don't think it holds a candle to PostgREST. Anybody else know of any like alternatives that kind of do this kind of same thing? I mean, you have ORMs. That's not really the same thing, though. So there's a few curiosities coming in the long run, I think, where database vendors are going to build this in. We have a MySQL HTTP API. You can actually download this and put it in production, but they stress very highly that it's not ready for production. You can do it in testing, you can do it whatever, but they tell you not to run it in production. I think that's a pretty good sign to not run it in production. PostgREST, the database, has a similar kind of thing. Unfortunately, it's not even past RSC yet. They're still developing it, so it's it's Sudden Valley, unfortunately. So I think feel free to independently verify my my findings, but I think PostgREST right now is sort of the leader. It kind of sits on the throne of the automatic API generation world. I don't even watch this show. I just know that's the thing. So one more thing. So we have to ask ourselves, what's the future of PostgREST? PostgREST, the project, is very active. I get notifications every day because I follow the project, and they're constantly working through issues. There's a lot of people that have a lot of interest in this project, and I think it's probably something we'll see a lot of growth in. Maybe not PostgREST directly, but other competitors as well. I think people are really going to like this idea and want to have it available for other technologies. So there are 66 issues open on PostgREST as of this morning. They say they want to build in more control over caching, more protection against deleting the entire database. They want to be able to automatically generate test data and a few other things, better RPC support. But I think what we're really going to see in the next couple of years is more competition. So in review, we know that REST APIs are very important. They're powering the modern web. If you haven't interacted with a REST API yet in your career, there's a really good chance that you will at least use one, if not be maintaining or developing one. So this is a really important thing that we need to sort of be aware of. And we also need to know that building and maintaining these APIs can be difficult. We saw the issues that we had with building the boutique kind of APIs, one for each customer. They all kind of look the same, and anytime you do that, it makes a maintenance nightmare. Or you have to update frameworks and things like that. It's a non-trivial task. We can spend a lot of our time just updating code to get it to work with the latest version, when I think a lot of us would argue that we had better things to do with our time. So PostgREST, it's not a panacea, but it can definitely make your life a lot easier. And I believe personally that we're at the start of a trend where we're going to see more of these types of things coming out in the future, really let us developers focus on the important problems that are important to our domain and not implementing a standard REST API. So that's my opinion. I think maybe the writing's on the wall a little bit, but that's kind of what I think. And guys, Thank you. It's been long, but that's the end of my presentation. Hour and a half. Sorry. Can you see why I didn't want to do that as a lightning talk? There's a lot of things, right? Any questions before I step down? Anybody? Yes, sir.
Really off topic, but where'd you get your stock photos?
When you Google free stock photos, it's the first result. It's called Pexler, I think. Before I got most of them, free. No, not just free. You want free stock photos. Pexels, yeah.
Okay.
Yep. I think they have some really great stuff on there, and it's all free, royalty free. You know, doesn't require any attribution or anything that I know of. I think. I mean, you know, fair use, I guess. So, anyhow, any other questions? Off or on topic? All right. That's it. I think we're good, guys. Thank you. Oh yeah. Bye-bye, guys.